So, are we live? I guess we are, right? So, can you guys hear me? Yes. Hello, guys. Before we go further, I want you all to stay at home, maintain social distancing. Okay. Maintain social distancing, stay at home, wash your hands regularly. All right. I want you guys to stay at home. I know it's a tough time, so take care. All right. Stay at home, wash your hands regularly. So, and along with that, crack IIT-JEE with India's largest platform, which is Unacademy. Okay. So get the plus subscription and access unlimited amounts of live and recorded courses from across India's best educators. Okay, get the subscription right away. It's pretty it's awesome. So before we go further, install the Unacademy Learning app. Okay, it's on the app like this. This is how it looks. So this is the symbol of it. It's pretty cool. And every day come to my test at 10:30. At 10:30 we have a daily quiz show which happens 4 times a week. Alternate 2 days, 2 times in 3 days. Daily quiz show. Okay, come to that show at 10:30. Search for my name N Srikant. Follow me there, and let's have lots of fun. Okay. So install the app right away. And about me, I am N Srikant. I did my BTech from IIT Kharagpur with an AIR of 385. I've been guiding you guys for the last 4+ years. I like to call myself a guide. Okay. And you guys call me human calculator. Yes, I'm a Sunrisers fan and it's very hard to be one right now. And DC is equally marvelous, if not better. I'm a DC fan. Yes, and this is the program. This is the program I've given for you guys. It's called Ad Astra, in which I will be covering the entire second year syllabus. I will cover the entire second year syllabus. Ad Astra means aiming for the stars. So aim for the stars and crack IIT-JEE. Okay. So this is the logo which I made. Cool, no? So if you like this, hit the like button right away and share it everywhere. Okay. So today we'll be discussing about Gauss law and electric potential. We will continue the problems we did yesterday. We'll do a few problems about metal spheres and all, and then we'll discuss electric potential and electric potential properties along with some problems. Okay. So this is the multiple plate problem we were doing yesterday, and we will finish this today and then go further. So the figure shows three large metallic plates of charges minus q plus 3q and q here. All right. There are there are three charges. There are three charges minus q, 3q and q. Okay. So now what are the charges on each surface? This is what we have to find. Here we will use the concept assuming that there are large metallic plates here. The assumption was that it's a large metallic plate. Right. So these are large metallic plates. So the main assumption is that the charge will be uniformly distributed everywhere. And we know the field due to metallic plates. The field due to metallic plates is density by epsilon. This is the main thing. We will keep using this a lot. And one more property we already know from this is that the field inside conductors will always be equal to 0. This is one more property we'll use. We discussed this yesterday. Hello, good evening, Sim24. We are continuing from where we left yesterday. So this was the problem we stopped. So we will do this today. All right. So let's take the charges here to be X. Okay, we'll take the charge here to be one more thing we know here. One more thing we know, the third property is that two plates which are facing each other will have opposite charges. Two plates facing, that is logic, right? Because when one plate has positive, the other will have negative, so that thank you. I didn't this hair got a little messed up today. But thank you, man, Sim24. So two plates which are facing each other, one side if it has positive, the other side will have negative, because electrons can freely flow in metals. So if there is positive charge here, all the negative charges will come to the other plate, this plate beside it, such that eventually this positive, this negative will balance. We discussed about this also in dielectric. Remember the amount of charges which form and how much field they form, all this, right? So using those both, we know two plates facing each other have opposite charges. So these are the three main logics which you know already. These are not formulas. Opposite charges. These are the three main logics we keep using in this problem. We'll use this in any problem of this sort. Even for spherical also we'll use the same logic. Okay. So this is the main property here. So now let's take the charge here is x. Let's take the charge here to be x. So the charge here will be minus x. Similarly, I'll take the charge here to be y. The charge here will be minus y. Okay. And here the charge will be minus q minus x. And here the charge will be q plus y. Getting it? Because the sum of the charges are given here. And one more thing we know here, that y minus x is equal to 3q. This is one equation we got. Right? It's pretty simple, no? Straightforward till now. Okay. Now for the next step. For the next step, not the next page. So at this point the field should be, let's take these points 1, 2 and 3. Field at 1 which is inside the metal will be equal to field at 2 which is also inside the metal, which is equal to field at 3. All the three places the field will be equal to 0. So we can solve using any of these equations. Any one of these equations we solve, we can get another equation on x and y, we can solve the whole thing. Right? Because how many equations do we need? We need two equations because we have two variables, y and x. So any one, let's take this plate. We'll take one only, just like that we will take one. We can take 2 and 3 or 2 or 3 and solve it also. Field at 1 equal to 0, which implies now we have to find field due to each side. Now, if you observe 1, the field on this side will be to the left, right? Field from this side will be to the left. Field from everything else will be to the opposite direction. Everything else will have opposite direction. Okay. And one more thing, let's take the area of each plate to be A, because density is charge by area. This is one more thing we'll use. It's there anyway. We know the direction of each field here, right? And we will start solving. Due to field 1, the direction will be in this direction, and the density of plate 1 is minus q minus x by a, and the field direction will be in this direction. It will be equal to minus q minus x by a epsilon naught, which can also be written as q plus x by a epsilon naught in this direction. Getting it? This is one equation we can write, and everything else we just add. Due to this we get due to sigma 2, due to plate side 2, we'll call them sides. We'll call this side 1, 2, 3, 4, 5 and 6. Due to side 2 we get density is x by a, and the direction of field will be this direction. So we can say field due to plate 2 will be x by a epsilon naught in the same direction which is mentioned here. And due to 3 also same, these both will get cancelled. If you observe, E3 will be equal to minus x by epsilon, they both will get cancelled. And similarly even this one and this one will get cancelled. Plates 4 and 5, field due to 4 will be equal to minus of field due to 5. Getting it? This is the magic, because we know this charge is y by a epsilon naught, and that is minus y, which means both of them which are having same direction and negative charges will get cancelled out. So what is the only remaining side? It is q plus y. E6 side, the charge is q plus y, so field will be q plus y by a epsilon naught. So now we add all of them and it will be equal to 0. From this what do we get? Q plus x plus q plus y is equal to 0, right? So from this we will get x plus y is equal to minus 2q, and we also got a y minus x is equal to 3q. You add both of them, what do we get? So these are two equations we got. Once we add both of them, we get the answer directly. It's pretty straightforward here, right? Let me just solve it here. Yes. So equating mode, just add both of them, we get 2y is equal to q, which means y is equal to q by 2, and x is equal to minus 5q by 2. These are the two values. And what is the total charge on both sides? So we can calculate it now. Directly we will get here minus q minus x, which is minus q plus 5q by 2, which will come out to be 3q by 2. This side it is 3q by 2. And here by same logic we will get it is equal to minus 5q by 2. Similarly on this it will be 5q by 2, and here you will get q by 2, and here you will get minus q by 2, and here you will get 3q by 2. So this is the solution, guys. If you like this solution, just hit the like button. You understood, no? The main logics we used are those three. One is that the field will be given by density by epsilon naught. Yes, you can start class 12 here, Prashant Moon. This is the place to be. I just started off. I will go slowly. Today we are going to do potential after this problem. So you can follow me in this channel. I'll cover the entire second year topics. Okay. But you are in class 11. One suggestion I'll give you, Prashant Moon, is solve more problems. Okay. Just get comfortable with first year. Comfortable with first year, especially mechanics. I want you to feel, understand the logic. Study a few chapters like vectors very thoroughly. Okay, vectors is the most important topic. Study vectors thoroughly and then revise it for some time and then go for it. Hi Adya, how are you? I'm good. Hi. So this is how we solve it, guys. Just substitute. The moment you get two equations, we're getting the answer. Pretty straightforward, no? So that is it. Now for analysis of hollow spheres, I want you to understand how hollow spheres work. Let's take hollow spheres having inner radius and outer radius, something like this. Okay. If there is no charge here, there will be no charge everywhere, anywhere. Okay. But what I mean to say is, any charge which is inside will eventually distribute off to the outside, because here also there will be some minus q. Whenever there is a charge q, analysis of hollow spheres, there is q here, there will be minus q on the inner surface of the sphere, and there will be plus q on the outer surface of the sphere. So this is how charge gets distributed, because we know the Gaussian surface here will have zero field. Understood? Understand, Gaussian surface. Gaussian surface is a spherical one. For all shells and spheres and point charges, Gaussian surfaces are spheres. Yes, it will generally be at 8 o'clock, but I will definitely make sure the timings get more consistent. I am planning to have more classes in the morning because it's better that time than at this time of the day. So I will think of shifting it to the morning time, and then we'll have continuous classes every day. All right. We'll definitely have a fixed timing. This if generally it is at 8 o'clock right now. Every day at 8 o'clock it will be there. Yesterday it was early at 5, but otherwise it's at 8. Okay. Adya, I will definitely let you know, Adya, once I have a proper plan in mind. I'm planning something continuous every day. Okay. So this is the Gaussian sphere I'm talking about. So in this case, if you take a Gaussian sphere here, the field inside will be 0, right? Which means the charge enclosed within that should be 0, and that is how this happens. Okay. And if you understand how the field works, how will it work? One thing we know, inside a hollow sphere, if there's a point charge, inside, at point charge at that place it will be very high, because field inside the sphere will be equal to kq by r square, and inside the shell, E inside the shell will be equal to 0, because shell is metallic, but air inside, whatever material is there inside, is not metallic. Getting it? So E inside the shell will be this. E in between shell, basically. Let's call it in between. Shell will be 0, and inside the shell, which is this area, the field will be because of this point charge, because outside part will not affect. So in the beginning it will be like this. Okay. Up till the point, let's call this radius 1 to be A. Up till A it will be like this. At this point the field will be kq by A square. This will follow the same graph. And the moment this stops from A to B, how will the field be? The field will be 0. Getting it? This is the magic part, guys. You have to understand how the field works inside a shell everywhere. So this is how the field will start, and then there will be a 0 here, and once it comes out again, it will start behaving like a point charge, right? Because everything is a Gaussian surface. So once it starts, okay, I'll use a better color. Just spare me this horror. It's looking very bad. Oh. So I'll draw a much better diagram with much better looking graphics so that you can understand everything clearly. All right. So let me take a graph. E versus X graph. Just one moment. Yes, perfect. E versus X graph. Okay. So how will it look? So in the beginning it will look like a point charge. It will come down like this up till the value A. Once it reaches A, the field here is KQ by R square the entire time. Because there is only point charge influencing it, and the shell which is outside will not interfere in the charge, will not interfere in the field, because that is not inside the Gaussian surface you're taking. Here you take a spherical Gaussian surface, there is no outside charge, will not affect this. Understood? So from A to B, the field will be 0 because it's inside the metal, and the moment it comes to B, it will again be equal to KQ by B square, and from here it will continue going down. So this is how the field graph looks. This is the analysis of it, guys. Hello Sairam Garu, hello Amma, hello Guru Ashish Reddy, welcome. So you're getting how the graph works, right, guys? This is very important. This is how you analyze it. Okay. So we have complete analysis example. Like I'm going to give you the full analysis about how field will work in between all of this. Okay. So a small conducting spherical shell with inner radius A and outer radius B. So this is one shell. We'll call this shell 1. And there is an outer shell with inner radius C and outer radius D. So this is shell 1, this is hollow. Getting it? So now he's saying the inner shell has a total charge of 2q and outer shell has a total charge of 4q. Simple hai baat. Inside there is no charge. Is there charge? There is no charge inside, right? Yes. So now we will start solving. There is no charge inside. So inside even this part the charge will be 0. If you analyze this diagram, let's analyze this diagram. Okay. So since there is no charge here, here also charge will be 0. Because if you include the Gaussian surface here, there should be no charge inside a metal, right? So here there is no inside charge, which means here charge is 0, here charge is 0, and the entire 2q charge will be on the outer boundary. And if you see this surface, we can directly say the charge here will be minus 2q, because we just discussed if two metals are facing each other, they will have opposite charges. Understood? So that logic we'll use, and total charge is 4q. So here the total charge will be 6q, because sum of both the charges there is equal to 4q. Now if I tell you this graph, I want you guys to answer these answers. Guys, you have to answer this. I will draw the charges. You tell me the answer. Second shell, which has minus 2q and plus 6q. This is A, this is B, this is C, and this is D. Now when R is less than A, which means inside this area, we'll call this region 1. In region 1, what is the field? Come on guys, I want you guys to answer this. Good evening Ashish Reddy, I want you to answer this, man. What is the field inside of everything? Okay, I'm going to start a timer also. Just give me one moment. Timer is here. Yes. Yes, the timer starts now. Tell me the answer for the first one, second one, everything. Yes, come on guys. It's an easy question. Once you get that, you can also go to the next one. When A is between A and B, when the radius is between A and B. Yes, we are done with the first one. The first one, inside here, there is no induced charge, right? If you observe, there is no inside charge here. If you observe the Gaussian surface, There is no induced charge in between. So from that only we can say that the field inside will be 0 because there is no charge inside. There is no charge in this surface, which means the field here will be 0. And similarly from A to B also, the field inside, there is no charge in between this, in this Gaussian surface, which means even the second answer will be equal to 0. Getting it? Yes. What about the third one when it is between B and C? Between B and C, what are the surface we have to take? Between B and C is this spherical surface, right? So if you take this spherical surface, what is the charge inside? Is it 0? It is not 0, no. There is some charge inside. This is 0 here and plus 2q there. As a result of which, at inside between B and C, the field will be equal to k into 2q by r square. Because there is 2q charge in between. Getting it? And so the answer for this will be k into 2q by r square. And what about C to D? Again it is inside a metal. This is inside a metal, no? So here again the field will be between C and D. Here this is inside a metal surface. This is inside a metal. The moment it is inside a metal, you can directly write the answer again will be equal to 0. Yes, I am explaining this. I gave you 1 minute to solve it and tell it here. And if it is not done by now, it's okay. This is generally for solving. When R is greater than D, in the outside of the entirety, you can solve this. Now do this. When R is greater than D, tell me the field. It's pretty straightforward. It will be just K into Q inside by R square. So this is what we'll get. K into Q inside is 2Q and total 6Q. 6Q by square, which is option C. So this way guys, we can solve all these problems. So from this, the graphical analysis is, if you want to draw the graph for this, how will the graph look? This is an interesting graph. From 0 to A to B to C to D and greater than D. So from 0 to A it is 0, and from 0 to B also it is 0 because this is inside the metal. And here suddenly from B to C we are getting the value to be 2q by r square. So it will follow this graph like this. And from C to D it's again 0, and from D again it will follow another graph of kq by 6r square. Kq by r square. Graph here is 2kq by r square. Got it? So this is how we draw the graph. The entire question is just a revision type question with which you can understand how to solve any kind of problem like this. And drawing graphs is a very nice way of just analyzing what you figured out just now. So this is how the graph will look. It might look very different, but this is the right answer, guys. इसमें एक अलग equation है और इसका एक अलग equation. इसका 6kq by r square है, इसका 2kq by r square है. Getting it? So this is how the graph will look. Hello Saket, hello physics. So this is one last question which is about, this is a mathematical analysis of it. The cube of side L is equal to 1 meter has one corner at the origin and of coordinates, okay. One corner is at the origin and extends along the positive x, y and z axis, which means its dimensions will be along positive x axis, positive y axis and positive z axis. So if you draw a diagram like this, it will look like this. Yes. So this is a wonderful graph, guys. This is how the cube will look. Every side is 1 meter. Okay. Now suppose the electric field inside the region is given by E is equal to 2 plus 3y j cap. E is equal to 2 plus 3y j cap. It is only pointing in the j direction, which is upwards. The field is only in the 2 plus 3y j cap. Getting it? So if the field is acting only upwards, what is the total flux which is the charge inside the cube is being asked. So this is the wonderful question, guys. Is equal to W times epsilon naught, the value of W. Okay, so how do we solve this? So one thing you have to understand, if the direction of the area is area vector, you know area vector is perpendicular to surface, is along the direction of field, only then there will be flux. If it is perpendicular to the direction of field, there won't be flux. Which means if you imagine a cube and the field is only in upward direction. Okay. So what will happen? These four sides will have this thing, right? So if you take a cube like this, I'm just trying to take a small example of a cube. Let's take this phone. Okay, let's take, this is the direction of field. Okay, this is the cube, and the direction of flux is only downwards. Okay, upwards. Or so in that case, this side, this side, this side and this side, all the four of them will be perpendicular to this vector, right? Because this area vector will be in this direction, and this side area vector will be forward, this side area vector will be to the left, and this side area vector to be to the back side. As a result of which, only areas which give flux is the lower surface and the upper surface. Getting it? Similarly, here also only two surfaces will have flux. There is some problem with the tablet we have. So what do we know from this? There is field only on two surfaces. Flux. One is the lower one and one is the upper surface. In this lower surface, y is equal to 0, and in the upper surface, y is equal to 1. Got it? So that is simple, right? So now, what is the flux flowing through the lower surface? Flux through lower surface will be equal to the field into area. Since we know the E and area are along same direction, here we can directly write it is equal to E dot dA. We can directly write E into area, which is how much? 2 into the area of this. Area of this is 1 meter square, which is 2. Flux is equal to 2. It's a numerical value equal to 2. And flux in the upper surface will be, now one more thing you have to observe here, the field is coming from upward and the area is downward, right? So I have to put minus here. One more thing you have to understand, the field here, area vector will be downward here and upward here, because it is for a closed surface, the area vector is always outward. Getting it? The area vector will always be outward. Yes, got it? So that is straightforward. So from this, you are able to understand this, right, guys? The field vector will be downward here and upward there. The top surface is upward and the lower surface is downward. The field on the other hand is up here, equal to 2, and at this point it is equal to 5. होगी बात. तो यहाँ पे 2 है तो minus e into a, which will get minus 2. On the upper part it will be e into e upper into area upper, which is equal to plus 5 into 1, which is 3. Okay. So now what is the total flux? Flux will be equal to, it's 5, sorry, this is 5. Flux will be 5 minus 2, which is equal to 3. And what is the field? What is the charge inside? Q enclosed by epsilon naught will be equal to flux. From this we can get Q inside will be equal to flux into epsilon naught, which is equal to 3 epsilon naught. That is the answer, guys. It is equal to 3 epsilon naught. The value of W is equal to 3 over. It's simple, right? So this is about it, and before we go further, crack IIT-JEE with India's largest platform, which is Unacademy, undoubtedly. Okay, so install the app, get the plus subscription to access unlimited live and recorded sessions from India's best educators, everywhere across the country, not just one place. So what you get at plus subscription is you get daily live classes, you will get structured course, you get daily live classes where the interaction is live and any doubt you have will be answered immediately. यहाँ पे थोड़ा delay है. Okay, and there are structured courses like you will have full package. You'll have the full course already ready made for you, so you can look into it and you can study whenever you want, and you will also have discussions based on that. And you'll have live tests and quizzes where everything, any doubts you have or any kind of test you want is available there. As I always say, I want you guys to write tests regularly, because only a test can help you to prepare for IIT-JEE. The subjects will help you crack the questions inside it, but cracking the exam, you need to write tests regularly. So you'll have unlimited number of live tests and quizzes there. Not only that, you'll have unlimited access to all the teachers from across everywhere. Live classes, recorded classes, everything. So take this, is pretty cool. The price of this is 38,500 for 1 year. Yही better है, because even if you want to take 6 months or 3 months, together the cost of them is greater than that of 12 months. So this is a much more economical deal if you want to crack it. You not only this, use the code NSS1 to get extra 10% off, and you will get it for 34,650. The price you'll get it for 34,650, which comes out to 2,888 rupees per month, which is 32 rupees for physics, chemistry and maths per day. मतलब एक दिन फिजिक्स पढ़ने के लिए it costs 32 rupees. Now this is it might look big in the big for 12 for the full year, but if you break it down to every subject which you have to study, it comes down to this price, guys. So it's a pretty economical deal. Use the code NSS1 and you'll get it for extra 10% off. And if you're cracking JEE in 2022, you can use this NSS1 code. You'll get it for 50,400, which is 23 rupees per day. So what are you waiting for? Go for it. Use the code NSS1. Yes. Not only that, this is an iconic subscription which has been introduced for you guys who are childish. I know all of your kids, but if you feel like you need a little help from teachers, generally a lot of you guys take help from teachers when you're preparing, right? And at this time of Corona, this is the closest to teachers you can get. You'll have a personal coach who will be guiding you, mentoring you across all exams and your entire preparation. He will align your preparation strategy. This is a loop here. A personal coach will help you with your test analysis and he'll plan a study plan for you. Everything will be given to you by the app, by the Unacademy group itself. So all benefits of Plus will also be available there. So this is for those who need a little more help, who are having tough times without a teacher with you to guide you. Okay. इसका कॉस्ट है 1 ईयर के लिए थोड़ा ज़्यादा होगा उससे. इट कॉस्ट 50,400 पर 1 ईयर. दिस इज रफली 46 rupees per day for a teacher who is guiding you through physics, chemistry and maths. So you can go for it. Use the code NSS1. This is when you will get the extra 10% off. This 10% off is applicable only if you use the code NSS1. Okay. So yes. Now for the next topic, guys, it is electrostatic potential energy. Okay. So what is happening here? If you observe, there is potential differences are current wires and suddenly there is a lot of fire which is catching. There's a lot of heat which is produced. How is this heat produced? How much is this heat produced? Why is it burning? Why do transformers burst? You hear the huge sound. Where does all the energy come from? That energy is only called electrostatic potential energy. This is a little cute description in a very nice way. So the definition of it, the electrostatic potential energy of a system of particles is defined only for conservative fields, and we also know that electric field is a conservative field. That is one of the first things we discussed. Gravitational force is conservative, electrostatic force is also conservative, so even electric fields are conservative fields. So electric field is also conservative. We define potential energy in it. Any energy, any field or any force which is conservative, you can define potential energy, right? So that is why even for electric fields we define potential energy. For a system of particles, we define it as a work done in assembling the system in a given configuration against the interaction forces between the particles. Getting it? So it is the force, it is the work done to make that system come to that particular place. Okay. So one thing you have to understand. So it is not. You also know it this way, that potential energy is defined as negative of the work force. This is a negative of the conservative force dot dr. This is also correct. This is nothing but the work done by external agent to bring the particle from infinity to the setup. Getting it? To whatever setup is currently there, from infinity you are bringing the whole thing and setting it up there. That energy work done by the external agent is only called as potential energy. Got it? So these are the two ways of writing it. Both of them are correct. Both of them are same. Okay, so now we'll define it first for basic two particles, because one particle it doesn't work, right? One particle bringing it anywhere, there is no external force doing anything. So without any work only you can slowly move it from one place to another place. It will only move by inertia. So there is no external work done in the case of one particle, but two particles, they will repel each other. No, when two positive charges are placed, they will repel each other, which means if you want to bring them close, someone should bring them close, like a spring only. Imagine like spring. If you want to bring a spring close, you have to push it, otherwise it will just stay away. Same way here also, two particles will stay away, so bringing them to closer place, you need to do some work. So generally, one logic I want you guys to understand, gravitation से ये different है, gravitational potential से everything will be almost same, except that here the potential energy for two positive charges will be positive. In gravity they will attract each other, so you have to stop them and keep them there. Getting it? So work done by external agent will be negative there, but here two charges will try to repel each other and you are bringing it there means you are doing positive work. इस logic से याद रख लो, don't need to remember big formulas. Understand, if two positive charges are there, the potential energy will be positive, and if one positive charge and one negative charge is there, the potential energy will be negative. Simple. तो इससे सीधा एक फॉर्मूला लिख सकते हो. ये इंटीग्रेशन ये सब छोड़ दो, उतना ज्यादा सोचने की जरूरत भी नहीं है. Just 2 point charges, work done by external agent will be positive. Hence you directly write off K Q1 Q2 by R, which is only defined as internal energy for the system. Understood? So this is it. And if two charges are of opposite sides, naturally it will be negative, which is what I just told you. It will be minus K Q1 Q2 by R. This, guys, is one logic I want you guys to remember. It is very important. Positive and two positive charges, work done will be positive, which means the potential energy will also be positive. Simple. Everywhere it is the same thing. If you are doing some work to put it at certain place, the work done there will always be positive, which means potential energy will be more potential energy. Like you are lifting a block and putting it on top, potential energy बढ़ रहा है, mgh जो हम पता है. Same way you are, and naturally it wants to fall down, you are pushing it up. Same way these two charges want to go away and you are bringing them to this place, which means the potential energy here will be positive. Pretty straightforward, guys. So this is one point I want you guys to note down and remember this. This is the logic with which you can solve all problems without confusion. ठीक है, पॉजिटिव नेगेटिव का बहुत कंफ्यूजन होता है लोगों का, सो दिस इज द वन वे टू क्रैक दैट. Yes. Now for multiple charges भी same story है. Yes. And before we go further, I will tell you a few properties of this. Okay. Multiple charges के जाने के पहले I will tell you some properties of one thing. Potential energy, the energy itself, it means it is scalar, right? Potential energy means by definition means it is scalar. And one more thing you have to understand, it is only dependent on final position. It is exact potential energy, you know that these are certain properties of potential energy you have to never forget. Okay, it is scalar and it will only depend on position. It doesn't depend on in which path it came or how it came or what is the curve of the path. All of these are immaterial. It will only depend on the final position. Getting it? Thanks, man. Ramesh, I look like a hero, anta. Thank you. Okay, so games aside, scalar and it is dependent only on final position. These properties of energy are a must to understand. If you understand this trick, every solving of problem will become easy. Okay, this is one thing you have to keep in mind very clearly. देख मैं एक बोलता हूँ, physics is not about formulas, it is about understanding these kind of trivial things. Okay, trivial things like you, if it is scalar, there is no need of direction. Of tension nahi hai direction ka. That is why energy method is used a lot of cases, because if you know it is scalar, there is no tension. No, just final position kya hai. Only depending on that you write equation. That is what makes writing equation easy. And physics is about writing equations. It's not about remembering formulas. It is about how you write those formulas into two equations and solving two variables. That is why, guys, in fact, yeah, again, even Sim24 said I look like Vishwak saying thank you. And one more thing I want to say, today's quiz, while talking about this, I decided today's quiz at 10:30, be there for sure, is going to be an IQ quiz. I want you guys to understand how to write equations. It won't be a physics quiz. I'm going to put many two equation quizzes, not more than two equation quizzes, 2 or 3 equation based IQ tests, so that you can develop your equation solving ability. It will be little more mathematics than physics, but yes, I'd like to feel different about it. Okay, so thank you both Ramesh and Sim24 for your valuable feedback. I think I will, let's see, because of the beard, no, I was planning to cut the beard, so okay. So yes, one more thing. Yes, today's quiz will be an IQ test. So tell everyone to be there, okay, at 10:30. And this is what I want you guys to do, because if you understand these particular things, writing equations will become so easy. Like two particles K Q1 Q2 by R. I didn't even integrate. By dimensional formula, I can say it will have dimensional formula same as energy. Okay, energy can be defined as F into S. So the dimensional formula, it is Newton meter. What do you call, the SI unit is Newton meter, which is also called 1 joule. Got it? 1 joule is 1 Newton meter. And then next, one more thing I want you to understand is that it is also, the dimensional formula will be m L power 2 T power minus 2, because one force is ml T power minus 2 into a distance is length, so we'll get the same thing. Dimensional formula of energy is ml power 2 T power minus 2, and the unit is joules. Simple. Okay. When there are multiple charges, I'll just add them. I'll just add individual potential energies. Due to these both, there will be one potential energy. Due to these both charges, there will be one potential energy, because, so first I'll explain this whole thing. Let's say initially there is only Q1 charge there. Only Q1 charge there. Which means to bring Q1 here, there is no energy required. To bring Q2 here, there is only potential energy due to Q1. Now to bring Q3 here, both Q1 will affect it and Q2 also will affect it. Getting it? So this is how you get multiple permutations. So each one charge, because of the other charge, will get affected. Getting it? So ultimately you can take summation of k q I q j by r square. I and j are two numbers. I and j are two numbers such that I is not equal to j. Getting it? And I will be less than j. So once you take the first particle you are bringing, you won't use that in the previous one again. So this is the best formula of remembering it. This is the logical way of remembering it. Those who are understanding maths, you can remember it this way. If you have trouble with maths, don't worry too much. You can just simply take 1 2 1 3 2 3. If there is extra fourth one, you will write 1 4 2 4 3 4 also. Extra 5, you will write 1 1 5 2 5 3 5 4 5. So that is the progression which happens. Further, there is a mathematical formula. You can write it this way. Those who are understanding, whose favorite subject is mathematics, I'll try to tell it to you this way. I is less than j and I is not equal to j, and k q I q j by r, not r square. My bad, is r. Getting it? So, oh, thank you. But yes, u is equal to, in this particular case, it will be equal to, now take 1 and 2, kq1 q2 by r3, which is r3 here, and 1 and 3 you will have r2, kq1 q3 r2 and kq2 q3 r1. So this is the total energy to bring it there. Got it? So next, one more thing, this I am telling early because potential energy in electrostatics can be better explained using electrostatic potential, because once you know what potential difference is or potential is, it becomes very simple. Just like we know potential energy is gravity. In gravity, what is that? Electrostatic potential energy is mgh. So you can also write potential, electrostatic potential, gravitational potential will be equal to gh. Getting it? Same way here also, because of charges there is a potential, right, which will be equal to k q1 q2 by r or something of this sort. Okay, so suppose if you are taking what potential, the definition of potential is the okay, wait, the definition of potential is the potential energy of a unit charge. Okay, you know potential energy now, right? Potential energy, you know the value, you can calculate value using multiple combinations, but the potential will be defined as some value u. Okay, the value of potential, electric potential, is equal to potential per unit charge, potential of a unit charge. Getting it? So matlab, if there is q charge there, the potential will be q times. So like if you see here, to bring this charge here, bring q3 here, if q3 is more, the potential will be more, that much times more. Getting it? Similarly, the potential here will be just like force. I'll explain it in much simpler way. You know u is integration of minus f dot dr, right? इसको ऐसे लिख सकते हैं, from infinity to a particular point, right? And if you want to write, force is proportional to the charge placed. So if you define force for a unit test charge, the force will be defined as F by Q naught dr, from infinity to r. This will end up coming out to be minus integration of E dot dr, because force at a particular point on a test charge is nothing but the field. Getting it? So this is how we define the potential. Getting it? So V is the potential energy per unit charge, which is also given here. V is U by Q naught. And by logic, you can say the potential unit will be joules per coulomb. So V is defined as U by Q naught, which is also equal to integration of minus E dot dr. Getting it? The actual definition of it is integration of minus E dot dr from infinity to the particular point. V at a particular point is defined by this. So let's read into the definition of it now. Electric potential is a scalar property of every point in the region of an electric field. It is defined for every point in a region, just like field is defined for every point in a region. Wherever field is defined, there you will define electric potential. Wherever field is there, there is potential. Getting it? At a point in the electric field, potential is defined as the interactive energy of a unit positive charge. If at a point in electric charge at Q naught has potential U, the potential is defined as U by Q naught. So this is the definition of it. There are two ways of writing it. One is VR is equal to minus integration of E dot dr. Another way, VR is equal to potential energy at the particular point by Q naught, which is the test charge placed here. This is the potential energy of the test charge. Getting it? So this is very simple, guys. This is how you write it. VR is UR by Q naught, which is V is U by Q naught. Q naught is the test charge and U is the potential energy of the test charge. Other way of writing it is VB minus VA is integration from A to B. So it is like final to initial. From A, if you are going from A to B in some random path, any path, the potential difference VB and VA. VB minus VA will be defined as integration of minus of the work done. No, it is similarly same logic here. Minus of the field dot dr, minus of the work done per unit charge. It is negative of the work done by conservative force per unit charge. बस वही है, उसमें ज़्यादा सोचने की बात नहीं है. Yes, correct. Now we'll discuss about electrostatic potential unit. The units of this electrostatic potential V is volts. It is a very standard unit. This is where we are going to link electrostatics with electrokinetics, okay, which is actually current. Electrostatics with current electricity. This is the link between electrostatics and current electricity, guys. This is one wonderful concept which unifies the entire electrostatic, everything, electromagnetism. The entire thing is unified by current. Okay, and potential difference is equal to IR is one formula everyone knows since they are a kid. Why do you know that formula? Because that is the core formula which runs across the entire thing. So you have to understand this. This is where electrostatic potential. This is the definition of potential, and the unit of it is volts, or it is also written as joules per coulomb, because it is energy per unit charge. And if you, as far as this goes, you can write joules is ml square t power minus 2 divided by coulombs ka matlab it is current into time, right? It's A into T. So from this both you will get the dimensional formula as ml power 2 t power minus 3 into A power minus 1. Wow, इतना बड़ा dimensional formula है इसका. But look at this, it is so complex because if you see the fundamental ways, it is so complex with so many multitudes of mass, length, time and current. But if you see in volts, it's the most fundamental. Volt is one of the fundamental units which will most fundamental derived unit which you will use across second year. Okay, so this is one more definition, electron volt. I want you guys to know what electron volt is, so I wrote it here. Electron volt is charge into potential difference. So by the look of it, you can know electron is charge and volt is potential difference. So from these both, from the word itself, you know electron volt is a unit of energy. This we will use a lot, so I just use this word here. And what is the value of it? It is equal to 1.6 into 10 power minus 19 coulombs into 1 volt. 1 electron volt is the amount of energy when 1 electron passes through a potential difference of 1 volt. And it is also equal to 1.6 into 10 to the power minus 19 joules. So it's a very small value. So I want you guys to remember this. So these are certain important things we have to understand before we go into this thing. Now one thing I want to understand with this example, we will understand a lot of techniques. Okay, I will explain you a lot of techniques only by using this example, guys. So it's a very important example. Work done by electric field in moving 10 microcoulombs from A to B is 5 millijoules. So work done by an external force, external electric field, sorry. Work done by the electric field is equal to 5 millijoules for a charge of 10 microcoulomb. Okay. Assuming this is a constant electric field. Okay, we'll take this as constant because it is tough to integrate the whole thing. Or we can do that also. It's not a big deal. Work done is this much, and Q is 10 microcoulomb. Even without that, we can solve. Not that we need this. So work done is 5 millijoules and charge is 10 microcoulombs. Now work done by the external force to bring minus 1 coulomb charge. So what is it given? The force. One moment. Yes, we're back. The work done by the external force to bring minus 1 coulombs from A to B. So if you bring 10 microcoulombs, this is by, so this is one logic I want you guys to remember very nicely. 10 microcoulombs is doing 5 millijoules work. We also know the work will be proportional to charge because we just discussed charge into V is only equal to U, right? So work done will be proportional to charge. Simple सी बात. Now work done by, so 10 microcoulombs charge के लिए work done by the field is 5 millijoules. So for minus 1 coulomb, what will the work done be? By unitary method you can solve it, right? By unitary method if you solve, this will be 5 by 10 5 millijoules by 10 microcoulombs into minus 1, which is coming out to be minus 500. So work done for 1 microcoulomb by the electric field is minus 500 coulombs, which means what is the work done by the external force? We know the body will maintain constant velocity. If it's not given, it means that it's moving slowly, which means the velocity will remain constant. Getting it? इसका मतलब ये है कि अगर 10 microcoulomb का work done by the electric field minus 500 joules है, तो work done by the external force will be exactly opposite of that. Minus work done by the electric. This is the condition for potential. Okay, in fact this is the condition for finding potential, because the definition it only this is the condition because we will take the change in kinetic energy will be 0 when we are defining potential difference and all. Got it? So work done by external force to bring minus 1 coulomb charge will be equal to 500 joules. Got it? Now work done by the electric field in moving the charge 10 coulombs 10 microcoulomb charge from A to B is 5 millicoulombs. Then what is this? What is the value of this? I'm going to give you timer, guys. This I'm going to give you this is a timed question, so your timer starts now. I'll give you 1 minute, so think about it. The work done by the electric field in moving 10 microcoulomb charge from A to B is 5 millijoules. Then so this is a different way of doing the same previous question. You're understanding it? This is a different way of solving the same previous question. Yes, Saket Physics, Sim24 and Ramesh. Come on. Before I need to stop this, otherwise. Okay. I'll simply use it for the previous one. Work done by the external force. Let me use just the previous inference. Work done by the external agent on 1 coulomb is on minus 1 coulomb is 500 joules, right? Which means work done on 1 coulomb will be minus 500 joules. So work done by external agent is minus 500 joules, which means work done by the electric field will be equal to plus 500 joules per 1 coulomb. What is potential energy? It is integration of EDR. It is nothing but the change in potential energy by Q, right? So we can also write VB minus VA is equal to UB minus UA by Q, which is also nothing but minus of the work done by the electric field by Q. Charge is 1 coulomb. So by charge. So in this case, using this logic, we can simply write it as um, work done by the x minus of work done by this. What is the work done? Minus of 5 millijoules by charge. That's it. Simple. Nothing. Everything is the same formula, guys. I want you to understand this. VB minus VA is UB minus UA by Q, which is nothing but minus of work done by the electric field by charge. What is the work done by electric field? Which is 5 millijoules. So the work done is minus 5 millijoules and the charge is 10 microcoulomb. So just find out this value. We calculated previously on it is equal to minus 500 volts, which is the answer here. Getting it? Yes, Sim24. Got it? Simple. Work done by the electric field, if you find out, negative of that by charge. Work done by the external force by charge. Understood? What is the work done by the electric field? It is 5 millijoules, which means negative of work done by electric field is minus 5 millijoules. And by charge is only potential difference. By 10 microcoulombs is the potential difference. Clear, guys? It's very simple. Next. So this is one very important point I want you guys. This is a theoretical question. In the same situation, if the charge doubles without change in kinetic energy, which means even now the kinetic energy is not changing, the same situation above, from A it is going to be work done by the electric field. Here is 10 microcoulomb charge is moving like this. Work done by this, work done by the field will be equal to 5 millijoules. Okay, if the charge is doubling, what will happen? You have to mark the wrong option. Okay, I'm going to give you 1 minute. It's a theoretical question, guys. You have to answer this question. Take your time and understand this and then go for the answer. If the charge is doubling, so what happens when the charge doubles? Will the force double? Yes, correct, right? Because field is fixed. When the charge doubles, the force will double. What is work done by field? Work done by the field is nothing but integration of negative of electric force. Work done by field is nothing but integration of the electric force dot dr. Right. Work done by electric force, electrostatic force will be integration of minus of that electrostatic force dot dr. We know force is proportional to charge, which means even F dot dr will be proportional to charge because same, it's just a multiplication factor of charge. So even work done will double. Yes, getting it right. The work done will also double. The field will also double. The force will also double. Will the potential energy double? Potential energy is nothing but the work done, right? So even potential energy will double. And what about potential difference? Potential difference, on the other hand, this is the uniqueness of it. Okay, that is why we use potential energy very often. Potential energy, on the other hand, is potential by charge. This will be proportional to charge. So if this charge is increasing, even potential energy will increase, but potential will not increase. Now this is the main thing I want you guys to understand. This is why potential is the most important topic. The potential difference between bodies will not double. This is the wrong option. Potential is independent of charge motion. This is independent of amount of charge moving from A to B. Of charge moving. So this is one major logic you have to understand. Okay, इससे थोड़ा problem solving will become very good. Half the what will half, man? Potential difference will remain same. It is independent of the amount of charge. Okay, it is not halved. Okay, energy is doubled, but one more thing will not change. Field will not change, right? Potential energy and field are independent of the charge which is moving in the field. Getting it? These both are very important. That is why we solve a lot of problems based on field and potential rather than energies, because we can generally derive it for any charge and then we can distribute it accordingly. Clear? Yes, very good. Thank you. Now one more simple question like this. Okay, this is a very simple question. Yes. A 2 microcoulomb charge is taken from infinity to a particular point in an electric field. without changing its velocity, which is what we discussed. Any such question, we will not have any change in velocity. That is the first assumption, which will also be given to you in the question. Okay. If the work done against the electrostatic force is minus 40 joules, work done against electrostatic force, which means it is negative of the work done by the electrostatic force, is equal to minus 40 microjoules, which means work done by the electrostatic force is 40 microjoules. Okay. So if electrostatic field is doing positive work, we know by default that the potential energy is negative, which also means potential will be negative, right? You have to understand these logics. When work done by external force is positive, we know from this that potential energy will be positive, which will also imply V will be more. Potential energy will increase. Think about it this way, which means V will also increase. If work done by the external force is negative, which means U will decrease, which implies the V will decrease. This is the logic I want you guys to understand. This way, you can just keep playing around with everything. Okay. So this is it. Work done by the external force is negative, which means the potential will also be negative. And same way, potential difference will also be negative. So at infinity, we define potential to be 0. So VB minus V infinity will be equal to minus 40 microjoules, which is the potential energy, which is the work done by charge. So we get VB minus 0 is equal to minus 20 volts. So potential at B will be equal to 20 volts. Simple, right? Minus 20 volts, I mean, yes. Got it, right? It is that simple, guys. Just if work done by external force is negative, potential will be negative, potential energy will be negative. And if the work done by the external force is positive, potential will increase. Just like we discussed again, potential will increase, same way potential difference will also increase, because potential difference is nothing but potential into voltage, charge. So all this is for a positive charge. Okay, but if negative charge is there, just everything will become reverse. You understand this logic, and once you understand this logic, apply it on negative in exactly the opposite way. Okay, you imagine it like negative mass. If you're lifting a block of mass minus m upwards, what is the increase in potential energy? Minus mgh, which is negative. Understood? So negative charge, you imagine it like negative mass, and then everything will become a little more simplified in explaining the whole thing. Got it? So that is about it, guys. Uh, so yeah, this is for that only. In fact, suppose I'll give you one more question. Suppose minus 2 microcoulomb charge is being pulled, and work done by the external agent is minus 40 microjoules, or work done against electrostatic force is minus 40 microjoules. What is the potential of point B now? Will it be plus or minus? Everything else is same except that the charge is now negative. So from this directly we will say potential will become plus. Because think about it in the same way again. Negative charge will always get attracted to a field, right? So external force, if it is anywhere, if it is getting attracted, it will get attracted to a lower potential. So wait, let me explain the whole thing again. Work done by the external force is positive, which implies potential will be more. So work done by the external force on a negative charge is positive, which implies that field will be less. Getting it? Work done by the field will be positive, will be positive, which will imply that the field is increasing. Negative charge. Getting it? So this is the main kind of alteration you have to understand. Okay. So let me explain this all in a simplistic way. There is a field here. Okay, I'll explain this whole thing how to simplify that. And there's a positive charge. The positive charge will flow along. So whenever there's a direction of field, just like gravitational direction is there, here will be lower potential, here will be higher potential. No, same way along the direction of field, this will be lower potential and this will be higher potential, because we know V is nothing but minus integration of E dot dr. So wherever field direction is there, their potential will reduce. The field is going in this direction, which means this is lower potential, this is higher potential. And plus Q charge will always move from higher potential to lower potential. What about negative charge? It will move in the opposite direction. It will move from lower potential to higher potential on its own. So getting these points? So this is the difference between both of them. Naturally, the field will do positive charge when potential energy is decreasing on this charge, on this. On negative charge, it will positive work when it is going to higher potential. So this way, everything can be linked. Got it? So the potential difference in this case now, work done by the external agent is negative, which means work done by the electric field will be positive. And negative charge is being attracted in the particular direction along the opposite to the direction of field. Getting it? And the work done by the electric field will be plus 40 microjoules. So what is the field now? It is delta U by Q, right? So from this directly we'll say 40 microjoules by minus 2 microjoules, which is minus 20 volts. Oh, minus 40 by minus 20, which is plus 20 volts. Getting it? So potential energy change is minus 40, which is nothing but the work done by external agent. By charge is minus 2. So you can remember this simple formula, man. Work done by external agent by Q is only potential difference. Clear? And we can also remember another thing. It is only U by Q, which is difference. And you can also write negative of work done by the electric field. We can also write it as minus integration of E dot dr. So all these ways you can remember it in multiple ways. Everything will lead to the same answer everywhere. Okay. So that is about it. Now electric potential due to a point charge, it is in its surroundings. Now what will this be? So here we will take a charge Q1. We will find out the potential energy of the charge Q1 due to the charge Q, and we will find out this thing right away. So electric field potential energy, we know it is just KQ into Q1 by R. So then what will voltage be? Potential be? It will be KQ Q1 by R divided by the test charge value, which is equal to Q1. So from this directly we will get KQ by R. Got it, guys? Simple. You know potential is a scalar. Potential is also a scalar. Okay. We discuss the unit, we discuss it as scalar everywhere because it's potential energy by charge. Potential energy is scalar, charge is scalar. So V is also scalar. So simply you can write the value due to a point charge as KQ by R. Got it, guys? Simple explanation. Now we will define it for a little more complex substance like field due to a rod. Okay, before we go to a rod, I will solve this ring. Field due to a ring at the center. One thing you know, if you put a test charge here, some Q dash, every charge here is at same distance, right? Every charge, the entire line charge will be at the same distance. This dq is also at same distance. Similar, this will also be at same distance. Everything is at a distance r. So directly we can write the potential will be directly equal to k into q total by r. Because it's a scalar, every charge will have it's the same distance from this point. So we can directly write here the potential here will be equal to k into q by, that's it. Simple, guys. Simple definition and simple solution here for you right away. And next, the potential at a distance x from this, like this. We know it is scalar, so only the distance between them matter. KQ by R, when we write this, it will only depend on the charge which is present, and the distance from charge. Clear? So here this charge plus Q is placed at a distance from this point. At what is the distance? Every point will have same distance again. So this is the magic of symmetry. Every point is at same distance. Every point is at a distance of k root over x square by r square. So here we can write potential difference as kq by root over x square plus r square. It is such a simple derivation. For when the distance between particles is same, we have a very simple derivation like this for you. Getting it? Now this is a little more complex. Potential due to a rod. Here we have to integrate, guys. So let's solve it. Potential, now let's take a distance x. Okay. Alright. Let's take a point at a distance x from this P. A dx charge. This is linear charge density, right? This is linear charge. So what can we say? Density lambda will be equal to q by L, which means dx will have a charge of for dx, the charge will be dq will be equal to from this we know charge is lambda into L, no? So same way we will get this is equal to lambda into dx. dq will be equal to lambda into dx. And what is the potential energy due to dq? Potential due to dq charge? V due to dq charge will be equal to k into lambda dx by x. सिंपल है, डायरेक्ट एकदम जो भी है फॉर्मूला सीधा उसमें डाल दिया है ना. So v due to dq charge will be equal to k lambda dx by x. So what is total potential? It is nothing but the sum of the entire thing, right? Because this is due to small charge. The total dv due to dq charge, the total potential will be integration of the entire dv. We can do k into lambda into integration of dx by x. What is the integration of dx by x? Dx by x? It is log x. So directly we'll get k into lambda into ln x. And what is the range of x? If you observe, it is from r to r plus l. R to r plus l. Substitute the whole thing. V will be equal to k into lambda into ln r plus l minus ln r. This is coming out to be k into lambda into ln r plus l by r. Now we define it in terms of charge, not in terms of q. So what will we do? We'll just take k into q by l. You know lambda is q by l into ln r plus l by r. So either one of these both you can remember and you can solve the whole thing. Or you can also simply remember it is integration of continuous bodies. For continuous bodies, field will be integration of dv. Because it's scalar, you just add the whole values, man. What is there? We just keep adding the whole thing. हो गया. Bas integration of small potentials. That's it. Now potential due to a disk. This is another easy question, but then you have to integrate this. Okay. So इसको थोड़ा integration simple करके कर दूँगा. What I'll do is, I know for a ring, right? I know for a ring it's equal to kq by root over x square plus r square. Now for this kind of body, how will it be? One thing we know, it has an areal charge density of sigma. Got it? It has an areal charge density of sigma. So now dq will be equal to sigma into dA, right? That's it. No, this is how small charge is there. Now a small ring like this, if you take, it will have small charge which is equal to sigma into dA, where dA is the area of this small part. The small part में जितना भी area है, the entire area has this charge density, right, of sigma. So the total charge will be sigma into dA. And now we can use the whole formula before. V due to a ring, due to a disk at a particular distance is given by k into q by root over x square plus r square. Okay. In this case, we took at a particular y distance, we took y. Instead of the radius, we are going to integrate y. So for dv now will be equal to k into dq by root over x square plus y square, right? Because the radius of this is y. At a y distance, I am going to take. What will this distance be? This is x, this is y, this will be root over x square plus y square. And this area is dy. So I'm going to substitute the whole thing now. What is the small area of this? एक ring का ring with a small thickness, ring of dy thickness, the area will be equal to circumference into thickness, right? So I can directly write 2 pi y dy over the whole thing is done now. So dv is equal to k into sigma into area, which is 2 pi y dy by root over x square plus square. Okay, but now I am going to convert k to 1 by 4 pi because it will become easy to cancel the whole thing. So I will get 1 by 4 pi epsilon naught into sigma into 2 pi y 2 pi. All of these are constants and I have to only integrate y root over x square plus y square dy. 1 by this whole thing is gone, you will end up getting sigma by 2 epsilon naught into integration of y root over x square plus y square. Now, how do I tackle these kind of problems? I have a very nice trick for these kind of problems. So these kind of integrations, I have a very nice technique. So what will I do? Integration of y by root over x square plus y square dy. Now, Numerator has y power 1 and denominator the coordinates have x square plus y square, which means the y power there is 2. So any kind of these questions, the differentiation of bottom will have some kind of numerator. So x square plus y square is what I will take it as some alpha. And I differentiate this y with y, what will I get? X is constant, right? So differentiation of y will directly come out to be 2y. Or I can also write dy will be equal, d alpha will be equal to y dy, d alpha by 2. So now one thing I got is I got of the numerator part here. And I know already denominator part is already there. So this is the simplest way to solve it, right? D alpha by 2 times root over alpha. हो गई बात, सिंपल सी सॉल्यूशन है इसका. So this will come out to be 1 by 2 times 2 into alpha power 1 by 2. Because alpha power minus 1 by 2 is alpha power minus 1 by 2 plus 1 by minus 1 by 2 plus 1, which is 2 times alpha power 1 by 2. सिंपल सी बात है. तो इन दोनों को कैंसिल कर दिए, तो वी आर सिंपली रिमेनिंग विथ alpha power 1 by 2 from y is equal to 0 to y is equal to y. Got it? So just give me one page. Yes. So what did we get? It is equal to sigma by 2 epsilon naught into integration of alpha power 1 by 2 from y is equal to 0 to y is equal to r. This is only the value of potential here. So just substitute the whole thing. By 2 epsilon naught into alpha is root over x square plus y square. So I'm going to substitute the whole thing. So is root over x square plus y square, which in this case is r, minus root over x square plus 0 square, which is x. So this is the potential. It might look a little lengthy, but the calculation has a little of integration, has a little of mathematics, has a little of potential. So this is a good question to understand. All right. So this is one way of writing it. And then one more thing, potential due to an infinitely charged wire. Infinitely charged wire का क्या होगा? देखो गाइस, इसमें क्या लिखा हुआ है? So infinitely charged wire, we will take a particular wire like this, which is having a charge density of lambda at a particular distance r. I am going to take this. Okay, I am going to take a particular distance r. So this is one more way of doing it. Okay, this is one way of doing it. Now I will tell you one other way. Okay, this is standard way. I have to take the charge density lambda and I will start integrating each individual charge. ऐसे ऐसे एक एक individual charge के कारण I can add. But this is what I don't want to do, because there is another simple method of understanding this. Whenever you feel it is little more clumsy, little more tough to take dq charges, you can also imagine potential as minus integration of E dot dr. इससे पूरा काम हो जाएगा. Understood? So if you take charge density lambda, I know field due to it is how much? Lambda by 2 epsilon naught into r. Got it? So this is the same formula I will apply now. Infinite charge from a particular point to a particular point. If you want to bring it from A to B, we can directly write potential difference will be equal to minus integration of E dot dr, which is equal to lambda by 2 pi epsilon naught into r dr. So इसको simply cancel कर दो, you'll get lambda by 2 pi epsilon naught into ln r from A to B minus of this. So this will get lambda by 2 pi epsilon naught into ln b by A is the potential difference. Getting it? So line charges, when it's moving from one place to the other place, we can take potential to be lambda by 2 pi epsilon naught to ln b by A. Okay. Due to hollow or conducting sphere or shell, each of these will have same potential, guys, because everywhere we are going to use integration of E dot dr. In these kind of problems, we'll just use integration of E dot dr. Okay. So one more thing we know, from infinity to a particular to the point on the shell, the entire shell or conducting sphere or hollow shell, hollow or conducting sphere, either ways the charge is on the outermost surface. Even on shell, the charge is on the outermost surface. So everywhere from infinity to the point on the shell, the entire shell will behave like a point particle. Right. So the entire time field will be equal to minus integration of E dot dr, which can also be written as K into Q by R. Simple C discussion here. Got it? Field dot dr, which is equal to KQ by R. By logic, you know how to find this. It is only KQ by R. So for point particle. So you can solve this till the point reaches the shell. Till R is greater than R. The moment it reaches the shell, the moment it gets inside the shell, field will be equal to 0. Right, inside the shell field will be equal to 0, as the result of which field will this, the moment this is constant, this is the 0, the integration of this whole thing will become constant, which means potential difference, change in potential will be 0, which means V will be equal to constant, guys. This is the major thing you have to understand. Whenever field is 0, when field is 0, potential will be constant. It won't be 0. The change in potential will be 0. Getting it? Change in potential is integration of E dot dr. So when field is 0, the potential difference will be 0, which also means potential is constant. So you can either say potential is constant or potential difference is 0. Clear? So this is the main thing you have to understand here. So till the point it reaches R is greater than R, till this point R, the potential is directly proportional to minus 1 by R type. It is all given by KQ by R, right? And the moment it reaches R, inside there is no change in potential, which means it will be constant and is equal to KQ by R. This is the main inference, guys. This is very similar to the gravitational potential you discussed. Same way here also, it will be constant and is equal to KQ by R from throughout the across the entire shell. Due to multiple concentric shells, everywhere inside, due to multiple concentric shells, there will be constant field due to outside shell. Got it? So we will do the same previous question now again. I'll explain the same previous question now. Okay guys, let's take multiple shells. Let's take multiple shells. One shell like this. Okay, this radius is A, this radius is B, and then another shell like this. This radius be C and this radius will be. Now let's put a charge here. Let's put 1 plus 4q charge here and plus 2q charge here, like before we already solved this problem. So I'm using the same things. Now we will start finding potential as we go through the entire journey. Now draw a graph of potential as a function of R. V as a function of R. I want you guys to understand this. I'm going to solve this, guys. You can solve it again on your own. If you want to solve it on your own, pause this and you can solve it. Okay. Pause this and you can solve it on your own. Otherwise, I'm going to explain this to you guys. It's a very wonderful concept here, because from what we understood in the previous case, we can use the same thing here. I had to do it. I wanted to do it. We will install a new page. Okay. So now from infinity to D. There seems to be a power cut, guys. So come closely. I'm coming closely now. Okay. From infinity to D, you can take the entire system will behave like point charge. Entire system behaves like a point charge. So directly we can say the total field, the potential will be equal to K into total charge by R, which is equal to 6 KQ by. Got it? From infinity to D, this is how it behaves. And the moment it comes to from C to D, from D it is going inside to C. In the entire part of the shell, we know that the field is constant, right? The field, we know the potential is constant. Potential is constant because field is 0. The field is 0 inside a shell, so the potential will remain constant. So inside, from D to C, the potential can be defined as 6kq by D, which is nothing but the radius till it reaches D. This is when R is less than equal to D. The moment it reaches D, it will become kq by D now, and it is constant. And again from C to B, what happens when it's moving from C to B? Again in this whole place, in this entire region, there will be field there because of the outer shell will have the same potential due to the 4q charge, but the inner shell will have extra, right? From the outer shell, everywhere it is coming in the same way. So here, whatever potential is, it will remain 6k by kq by d. But the moment it is coming inside, the inner shell potential will keep increasing, right? It will be V1 due to outer shell plus V2 due to inner shell. There are two things now. The outer shell will have a fixed thing. V1 will be equal to 4kq by d, which is only the charge on the outer surface by d. And V2 will be equal to the charge inside, which is 2kq by r. Wonderful, right? This is a wonderful equation. So from this, V from C to B will be equal to 4kq by d plus 2kq by. Understood? Now from C, once we reach B, which is this point, from here invert this, again here field is constant, and here also field is 0, here also field is 0, and here also field is 0. So once you reach C, once you are at C, what happens? Once you are at C, there is no more field inside. Field inside is always equal to 0, right? The field inside is always equal to 0, which implies that potential inside will always be constant. And how much will that be equal to? Equal to the potential at B. At B. What is the value of potential at B? It will be equal to 4kq by D plus 2kq by D. That's it, guys. So this is the wonderful solution. So now if you want to write everything individually, let's write everything individually from infinity to D. We will get field is equal to 6kq by R. From D to C, we get it is equal to 6kq by D. And from C to B, we get it is equal to 4kq by D, which is potential due to outer shell, plus 2kq by R, which is the potential due to inner shell, which is behaving like a point particle. This will be the inner shell, which is behaving like a point particle. And this is the outer shell, which gives constant potential difference, which gives V constant. Getting it? So this is how you break it down into pieces, guys. The moment you understand this, you can write this equation very simply. All of you, I would like you guys to do it by yourself also. From C to A, C to D again. From C to B. One moment. Okay, this whole thing is from C to B. Yeah. From B to inside, the entire place, the field will be 0, which implies potential is equal to constant and is equal to potential at B. Getting it? At B, what is the potential now? This thing is constant, this thing will depend on the radius. So directly we can write it is equal to 4kq by D plus 2kq by B. From B to the entire thing. Now if you want to draw a diagram for this, let's draw it here. So let's take the entire thing like this. From infinity to a point D, from D to C, C to B, B to A, and A to 0. From infinity it is coming like a point charge, right? From infinity it is behaving like the entire thing will behave like a point charge. So we can take the entire thing to move like this. It is going like a point charge. You will have 1 by x ka graph. This will be equal to 6kq by r. It's a 1 by x function. Okay. And from C to D it is constant. Right, and at C it is equal to the whatever value it is at C. From here it is increasing again further by another function which is given by 2kq by r. This is also inverse square function, and from C here it is behaving with a constant. This value will be equal to 4kq by D plus 2kq by B. It is always equal to the charge on the outer surface type. Okay, charge on the outer surface by radius of the outer surface. Simple, that's all. And this value will be equal to 6kq by d. Got it? So this is it, guys. This is a wonderful description, and this is a little inference from what we discussed today. Okay, little inference about what we discussed about potential difference. Potential difference between 2 points in an electric field can be defined as work done in displacing unit positive charge from one point to the other. Like we discussed, it is work done by one unit charge. Work done in displacing one unit positive charge. It is work done by external agent in displacing one positive charge, 1 point charge against electric forces. This is against, which means it is negative of the work done. This implies it is negative of work done by electric field. So everything we discussed work done by electric field, you can discuss the entire thing this way. If a unit positive charge is displaced from point A to B, it's displaced from A to B, then VB minus VA is minus integration of E dot dx from A to B. Understood? This is one formula. Another way of discussing it, change in potential. I have like to explain this as change in potential is integration of E dot dx. This is only what I read standard for potential energy also. Change in potential energy is negative of work done by external force. Got it? It is not potential energy. It is change in potential energy. That way you can simply derive a formula for that also. Okay. If charge plus Q is shifted from A to B, work done against electric forces can be given as work done is Q into VB minus VA, which is exactly what we already discussed. Okay, work done will be charge into potential difference. Okay, work done against electric force. Work done by the electric force will be equal to minus of change in potential into Q. Exactly ulta. Change is final minus initial. So work done will be equal to change in potential energy into Q. Simple, both are same. If VB is less than VA, then charge must have a tendency to move towards B. Like we discussed in gravity, gravitational, it always tries to move from higher potential to lower potential. Same way here also, positive charge will always try to move from higher potential to lower potential. And electrons, which have negative charge, will move from lower potential to higher potential. Understood? So this is all you guys have to understand, that charges flow from higher potential to lower potential. This is another main important thing which will be used in future problems. Charge moves from higher potential to lower potential on its own. Just like a ball will move from higher potential to lower potential on its own. Understood? This is how it works. Same way charge moves. But negative charge moves from lower potential to higher potential because it is moving against the direction of electric field. So this is the major thing, guys. So that's all for today. Tomorrow we'll come up with a lot of problems on electric potential and many we'll discuss a lot about potential, and in fact I will try to link everything into single logic so that anything you can solve the other way. If you know potential difference, you can find out electric field. If you know electric field, you can find potential difference, you can find work done, you can find potential energy. Everything you can solve based on understanding one single concept. Any one you understand, you can solve the other. So this is how I'd like to put it. Instead of putting many formulas, this is how I'd like to do it. Tomorrow we'll have this, guys. Don't forget, come tomorrow from 8 o'clock to 10 again. Tomorrow we'll have the same class from 8 to 8 p.m. onwards. Stay tuned in. Come there for sure. Okay. Adios amigos, and don't forget, when subscribing for Plus, use the code NSS1. Alright. So until next time, it's bye bye.